Hi everyone, my name is Chris Ryder and my presentation is going to be about Ghidra. So what is Ghidra? Ghidra is a reverse engineering tool framework created by the NSA, the National Security Agency. It was released in March in 2019 at the RSA conference, so it's very new and is now free and open source to the public. So these are the slides from the RSA conference in which it was first released. Is get your free NSA reverse engineering tool, and then a picture of Ghidra. Right, so let's go over installing Ghidra. It's fairly simple. Meet the basic requirements. Just download Ghidra from the website and extract it, and open it up. As soon as you first run it, you'll be greeted with this help page. The minimum requirements for installing Ghidra is at least 4 GB of RAM and 1 GB of storage, any 64-bit OS, or I should say Windows 7 or 10, and any Linux distro, though they do recommend CentOS 7. And for Macintosh, you're going to need 10.8.3 or later. And in addition to that, you will need a Java 11 JDK, though they recommend using OpenJDK, which I used in my project. Downloading Ghidra, you just go to this website, ghidra-sre.org, and click the big download link. There are also different releases. You can also look at the source code, the GitHub source code. Again, it's open source, and you can check that the downloaded correctly by double checking the sum. Checksum if you would like. Alright, so getting started in Ghidra, some very basic usage. First, you're going to need to create a project. You'll be greeted with this page when you sign in. It says no active project. Just click File, New Project. Choose non-shared project or shared project. Keep in mind that if it's a non-shared project, sometimes you have to jump through some hoops in order to open it as a different user if you have a different username, if you're going to be transferring the project. And a shared project is usually if you're going to obviously be sharing it with somebody else or hosting it on a server. Type in the project name. Here is my project. This is the directory where it's stored in. The username I have is Dragon. And there are also some classes included in the Ghidra files. So this is Ghidra, the latest version, 9.0.2. If you go to docs, Ghidra class, you can find beginner, advanced classes, and some exercise files, all created by the NSA. These are wonderful tools for beginners. Okay, so I had two projects. I looked at Stuxnet, just kind of a basic opening in Stuxnet and creating the VM, and then I looked at more detail on the WannaCry malware. So Stuxnet, for those of you who don't know, is or don't remember, is a worm and a rootkit. First discovered in 2010, thought to be developed in 2005. It was extremely well advanced, especially for at the time. It was suspected to be American and Israeli designed because it seemed to target Iranian centrifuges, and it would make them spin a little out of whack and damaging them. This here is a photo of the one secret nuclear complex in Natanz, Iran, which was a suspected target of Stuxnet. The rumor going around is that Ghidra cannot be used with Stuxnet. That if you open Stuxnet in Ghidra, you get this error message saying, "Whoa, buddy, this looks complicated. Why not go outside and enjoy nature instead?" So let's see if that's true. First, we need an environment. So I did this in a VM. I created the VM with a CentOS 7, 64-bit operating system. So create the virtual machine, install it from an ISO, make sure to update. then install Ghidra and open JDK. I wanted to make sure that the malware couldn't escape. So to isolate the VM, you can or cannot use VMware tools. Probably a good idea to disable drag and drop, and definitely no shared folders between the virtual machine and your host operating system. Downloading Stuxnet, you can go to this URL and download the zip file here. And verifying it, I uploaded the file to VirusTotal, which gives you the really detailed lots of information about what this malware is doing. So here you can see a graph showing what each file is calling, and it will also show you what different antiviruses have identified the malware as. Okay, so launching Ghidra from Linux host, you just run this command, launching this file. In Windows, you're going to need to use the bat file. We created the project already, so we're going to import the files, the Stuxnet files. So choose a file, batch import, and select the Stuxnet zip. Change the depth so it can find all of the individual files. Here I had to change it to 4 and click OK to import. Here you see me adding the files. So we imported the files, and next we have to open them. You choose File and Open here and choose the file you would like. Make sure to choose the analyzer, Windows PE, and then click Analyze. And you'll be greeted with this is the file behind it. This is the error message that comes up. This is a very common error message. This happens to most files you're going to open. You just click OK, and you can continue. And here's the error message that they claimed occurred on Twitter. So obviously these are not the same, and this is not true. This was actually a joke that many people took seriously. So for my second project, I chose to look at WannaCry, which was really the bulk of my project. In WannaCry, I used Ghidra again to analyze it. WannaCry was a worm that would go around and encrypt all of your files on your computer and display this message saying you had a certain amount of time to pay a certain amount of Bitcoin before you would lose your files forever. So I went and downloaded it. You download it and import it again the same way. Here Ghidra recognized it's an executable file, so that was easy. And double click on WannaCry after you import it in order to open it. Right, so here again, as soon as you open a file in Ghidra, it'll ask to analyze it. Click yes. Choose the decompiler parameter ID as well as the Windows PE86 external analyzers, and click Analyze. And if you would like to see functions, which a lot of people do, you can click Window and Functions, and you can start looking at the different functions that Ghidra found during its analysis. Okay, so what I wanted to do for this is a long process of analyzing WannaCry, which I would like to give credit for to Ghidra Ninja, which I'll show you his URL later, to help me kind of walk through this process of analyzing WannaCry or reverse engineering it. So I'm going to give you a few common tasks you would do in reverse engineering, and then walk you through analyzing WannaCry. So one task is to edit function signatures. Ghidra does recognize a lot of functions correctly, but sometimes it won't. And to identify those functions, you'll need to download the signatures from Microsoft Docs, here, docs.microsoft.com, and edit them in WannaCry, or edit them in Ghidra. So for WannaCry, they did not recognize the Windows main function, so we begin with entry. Entry is the first function that is called by the exe file. So taking a look at that, looks like a standard Windows executable. So we went down here and found the function that it's going to call, and we're going to edit the function signature and replace it with Microsoft's signature for the Windows main function. So we copy that here, go to edit function signature. It'll look like this. Replace all of that with Windows signature, and then edit it to match your file. So for WannaCry, it will look like this, and you just click OK. And now, again, click this and OK, and Ghidra will be able to recognize this as the main function, and you can continue from there. For WannaCry, we also had to do that for Internet Open A and Internet Open URLA, where we got signatures from Microsoft. I went through the same process to add the signatures into Ghidra. For Internet Open URLA, there was a problem and was greeted with this can't resolve data type each internet. So I thought I'd explain that. Here, Ghidra doesn't recognize that, so you need to create a custom type, which you might have to do in your Ghidra from time to time, so it will recognize H internet or anything, and we can add we can add this function signature. So to do that, we click abort changes and cancel. In data type manager down here, right click, click on new and type definition and add the name. Here H internet is just a void pointer, so we add this and click OK. And then now we have that custom type. It'll let us add the function signature, so we replace this with this and change we add this. All of this is the Microsoft function signature, but note for Internet Open URLA, we had to replace void with H internet. Okay, so we can edit function signatures. If we find the main function, we can add the Microsoft function signature, so Ghidra will recognize it. Now let's look at editing variables. To do that, in the window main, so for WannaCry, we found this strange URL, and we wanted to rename that. Rename this variable. You're going to be doing this all the time, I'm sure, if you're using Ghidra. So you can just Control L and rename the local variable to anything you would like, so you can continue to follow it. So here, for this, we renamed it strange URL. Okay, so we talked about function signatures, edit variables, some common tasks. Now let's look at analysis of WannaCry. So the first function, the main, it tries to call this strange URL. Okay, if it fails here, then it's going to call this other function. FUN is just function, kind of a general name Ghidra gives it. So it calls this function here. So we're going to take a look at that. So we renamed it WannaCry real entry. And by the way, what's the URL? It's the famous kill switch. So for those of you that are familiar with the story of WannaCry, early on, I guess a security researcher found a kill switch in WannaCry based upon, I think, DNS queries, and he was able to grab the domain and block it, and from that it stopped a lot of people from WannaCry from phoning home, and a lot of people that got infected actually didn't have their data encrypted at all because of that. Right, so WannaCry, the second function we jump to after main is this, and the function from before is here. So we renamed it WannaCry real entry, and this is what we get. And it just looks like it's calling. If we get less than 1 from an argument, we're going to jump to calls another function. So let's look at that third function. And this third function just calls two other functions, these two here. So looking into those, the first called function, we renamed it create WannaCry service, and this is it. This function creates two services, MS Service 2.0 and Microsoft Security Center 2.0. If you have these, you have WannaCry running on your system, because these are set to be created and then used to encrypt your files. So this this function creates those services and sets them to start at boot. Okay, so that's the first service. That's the first function. What does the second function do? All right, the second function is much longer, and within all of that, there is after we changed a lot of these variables to kind of make sense of it, and what we discovered is that all this calls for this resource 1831. And writes the 1831 resource to a process. So we have to go figure out what this resource 1831 really is. To do that, we use the tool REST tool, a Linux tool, and here's the command is REST tool WannaCry, and it tells us all of the resources within the file. Here we see 1831 is a resource being used. So we can extract it with this command here, extracting it to 1831.bin, and then file 1831.bin just to get some information on it, and it looks like this is an executable. So we're going to import that file into Ghidra and see what we get. Right, importing it into Ghidra, and we analyzed this file, looked at it, and the strings. In the strings, if you look at the strings, you're able to find some Bitcoin addresses. You're able to find the WannaCry just in plain text. And after looking at it farther, we're able to figure out that resource 1831 calls another resource 2058. So a function in the 1831 bin calls another resource 2058. Again, using REST tool shows us that 2058 is indeed a resource being used within 1831. So we extracted it here to 2058.xia and did a file to see what it is, and it's a zip archive. Right, so we tried to unzip it, and we're greeted with this asking us for a password, so it looks like this is an encrypted zip file. So we look back within the 1831 bin file executable, and we realized that there was a string here that was being put into the function, and we used this string to see if it worked as a password, and it did. Inserting this string as a password decrypted all of the files. Right, so these are a list of all the files that were decrypted. And using file command in all of them gives us a little more information. Here we see a text file and a bitmap file and another zip archive. Right, opening the bitmap image file reveals the WannaCry Desktop background, which is this. If you had WannaCry on your computer, it would be your background will be replaced with this. It says, "Oops, your important files are encrypted. If you see this text, please don't use the Wanna Decryptor. But don't see the Wanna Decryptor window. Then your antivirus remove the decrypt software, or you delete it from your computer." So this is a scary message you would see as your desktop background. Right, looking at the text file, r.wnry reveals the ransom note, which is this, showing you that you need to pay, send certain number of bitcoins to a certain address, and we will decrypt your files for you. And looking at the text file c.wnry reveals the .onion or the Tor links and a link to a Tor project. Okay, so we found the WannaCry malware within the resource 2058 in a resource 2058 in an encrypted zip file. So I wanted to thank huge thanks to Ghidra Ninja for his tutorial, who helped me walk me through this project. I'm pretty new to reverse engineering, and this was a huge help. I would not have been able to do it without his tutorial, which you can find here. If you'd like to do this process, just go to this link and search his name. He has a YouTube channel, and find his you can find his tutorial. Here are some other sources that I used during my project. Okay, guys, thank you. That is it for the Ghidra project. Before going, I wanted to talk about a little bit about how this went. To do that, I figured I'd show you my project updates. This is the first project update where I had a timeline of every few weeks completing a few objectives. I wanted to research other reverse engineering tools, prepare a lab environment, set up Ghidra, go through documentation, go through all of the NSA labs and everything, and then download some malware samples, analyze those, write reports, and I don't think it's here, it's down here, but I was actually thinking about stress testing it as well. Well, the stress test didn't make it, did not make the cut. What ended up happening, this is the very final project update. I researched other tools. I was able to prepare and create an environment and test Ghidra, find and download some samples, malware samples, and set up Ghidra, test its functionality, and then at this time I was still going through the project of analyzing WannaCry. So it worked pretty well. I just had $100 in electricity costs for I was able to do this on my desktop computer, so it wouldn't cost very much, and I think that it's worked fairly well. I would have liked a little more time. I think to poke around Ghidra a little more, but it is kind of a rabbit hole. There's so much to learn about reverse engineering that this project could have been a year, and it still wouldn't be done. So in the end, I think I was happy with it. It was within budget constraints, and I was able to get a result to extract malware from WannaCry. So thank you guys for listening, and thank you very much for listening to my presentation about Ghidra.